Welcome to the class. Today we are going to discuss the chapter solution. It is a very important chapter. Before we start solution, we have to discuss about some terms which will be used in this chapter. So for that we have to discuss what is solution. Solution is a homogeneous mixture. Solution is a homogeneous mixture of two or more components. Homogeneous mixture of two or more components. That we are saying it is a solution. What are the components? Components are of two types. One is solute, another is solvent. Now, before we start, we have to know what do you mean by homogeneous. Homogeneous means when we add two or more different substances together, if you can find out or I can identify the distinct components, then we will say it is heterogeneous. But what if you cannot identify which component is present? Just like if I am adding water to oil, we can clearly observe that it has two components. Oil and water can be identified easily, so it is a heterogeneous mixture. Now what if I add water to alcohol? So we will find it is quite difficult to identify whether this mixture contains water or alcohol until you drink it or taste it. But by observing, you cannot identify. That's why it is homogeneous. So always remember, if you are getting a mixture, by observing, if you can identify that different components are present in that solution, then it is called heterogeneous. But if you are unable, not capable to identify that different components are present, for you it seems to be one component, then it will be called homogeneous. Understood? Now, when we add something, that is called solute. This is also known as dispersing phase, and this will be dispersing medium. Now, what is solute? Solute is a dispersing phase which get dispersed in dispersing medium or solvent. Similarly, solvent is a dispersing medium in which solute get dispersed. Consider I have taken a container that which contains water plus sugar. Now here I can clearly know or can see that sugar will be dissolved in water. That's why sugar is treated as solute and water will be treated as solvent, and the mixture will be called solution. And the process of making that solution is called dissolution. Remember that the phenomenon of preparing solution is called dissolution. Now we understood that what is solute, what is solvent, and what is solution. So on the basis of physical state, that there is three physical state: solid, liquid, gas. So we can say that solute can be present in three states, or solvent can also be present in solid, liquid, gas. In this chapter, for us, solvent will be liquid always. Solute can be solid, liquid, or gas. For us, or in this chapter, we will think that solute may be present in solid state or liquid state or gaseous state. But for us in this chapter, remember that solvent will always be in liquid state. But practically solvent can be in solid, liquid, gas. But for this chapter, we will treat solvent always as liquid state. Understood? Next we can proceed. Now in solution, it is important to find out how much solute is present in solvent. That presence of solute in solvent or solution is called concentration. So what term we get? Concentration. So what is the amount of solute present in given solvent or solution is called concentration. On the basis of requirement, concentration is further classified into following types. One is strength, then percentage, parts per million, then normality, molarity, molality, and mole fraction. So there are 7 types of concentration, that is strengths, percentage, parts per million, normality, molarity, molality, and mole fraction. That what is strength? Now we will discuss what is strength. Strength is denoted as S. It will be the number of grams of, or we can say amount of solute in gram present in 1 liter solution or volume of solution in liter. That is strength. Now what is percentage? Percentage is just like normal. It can be mass by mass percentage, mass by volume percentage, volume by volume percentage. So always remember, our numerator presents to solute, while the denominator part may related to solution or may related to solvent. In maximum cases, means more than 90%, it will be solution. Very rarely we use solvent as a concentration term. And so many formulas are there for concentration which may depend upon temperature or which may not depend upon temperature. From gaseous state we know that PV equals to NTR. So we can see that temperature term is related to pressure and volume, and also number of moles. So always remember, if the formula contains a volume term, then this will depend upon temperature. Similarly, just like we can see strength in the formula of strength, we see there is a volume term. So strength depends upon temperature. For a particular temperature, the solution have a fixed strength. If the temperature changes, means it can be increased or decreased, then the strength of the solution will increase or decrease. Consider, we have taken that what is the strength if 4 gram of sodium hydroxide, is dissolved in 1 liter solution. So we can say that strength will be 4 gram divided by 1 liter. So it will be 4 gram per liter. So this will be the solve. Now we will discuss about percentage. In case of percentage is further classified into 3 types, that is mass by mass percentage, mass by volume percentage, volume by volume percentage. So what is mass by mass percentage? Always remember that numerator part is solute, denominator part is solution. So we can say that mass of solute divided by volume of solution into 100. This will be the mass by mass percentage. Similarly, if it is asking mass by volume percentage, just I discussed about mass by volume. If it is asking that mass by mass percentage, our formula will be mass of solute divided by mass of solution into 100, and this is the formula of mass by volume. So whatever it is saying, that if it is saying mass by mass percentage, then we will say that is mass of solute upon mass of solution into 100. That will be the formula. Here mass should be in grams, volume should be in liter. If volume is not given in liter, then we can convert it into liter. If it is volume by volume percentage, then volume of solute divided by volume of solution into 100. That is our percentage formula. Now what is ppm? ppm stands for parts per million. It means parts per million. Now question is, what is million? Million means 10 lakh. 10 lakh means 10 to the power 6. So we can say that number of parts of solute divided by number of parts of solution into 10 to the power 6. This is our ppm formula. Very minute particles or solution containing very low concentration of solute, then we will follow the ppm. But here in this chapter, molarity and mole fraction is very important for exam point of view. We will get variety of numericals on the basis of molality and mole fractions, and some on the basis of percentage. Understood? Now we will discuss about molarity, that it is capital M. It is the number of moles of solute present in volume of solution in liter. So this is our formula, that number of moles of solute per volume of solution in liter. If the volume is not given in liter, then we can convert it into liter. Now what will be the formula? Always remember, here 1 will be denoted as solvent and 2 will be denoted as solute. That's why I am taking number of solute is N2 by volume of solution V, and normally volume is given in liters, milliliters. That's why I have to convert it into liters by dividing 1000 with volume, that will be treated as into 1000. Now what is the number of moles? Given mass, that will be W2 by molar mass, that will be M2 into 1000 by volume. This is our molarity formula. Now next, what will be the molality? Small m, it is symbolized as small m, number of moles of solute divided by mass of solvent in kg, kilogram. So similarly we can say it is N2, number of moles of solute, divided by mass of solvent. I told you that solvent will be treated as 1 means will denote as 1 and solute will be 2. That's why I'm giving W 1. And normally mass is given in gram, so for converting it into kilogram I have to divide with 1000, so it will be written as 1000. So our formula becomes small m equals to N2. N2 can be written again like that, given mass, that is W2, by molar mass into 1000 divided by W1. So this is our formula for molarity. In case of molarity, we can see we are using volume term, so it depends upon what? Temperature. There is no volume term in molarity, so it is independent of temperature. Now what is the relationship between molarity and molality? Let's find relationship between molarity and molality. Let's write the formula. Molarity, we found that W2 upon M2 into 1000 divided by volume, while molality is W2 upon M2 into 1000 upon W1. So, and we have a formula of density, that is mass upon volume. Sorry. So if we are getting density of solution, so it will be D. Mass of solution, mass of solution is mass of solvent and mass of solute. Mass of solvent is W1, mass of solvent is solute is W2. What is mass of solution? Solution is a mixture of solute and solvent. If I am asking that mass of solution, it means mass of solute means sum of mass of solute and mass of solvent, and we have taken W1 is the mass of solvent and W2 is mass of solute. That's why mass of solution becomes W1 plus W2. And what will be the volume of solution? That is V. We have taken already. Now here we can see we have so many unknown terms, and most important thing, in solution both solute and solvent are present, but we always discuss in terms of solute. Whether you are taking food, you never say that water is more, you always say that this taste is salty, it means it contains more amount of salt. So we always discuss about in terms of solute. That's why we will convert solvent term into solute. That's why I have to find out the value of W1 here and volume. So let's find, from molarity we can find the value of volume. So what will be the formula? Volume is equals to W2 upon M2 into 1000 divided by capital M, molarity. Similarly, here we can find out W1. So W1 is equals to W2 by M2 into 1000 by small m. Now putting the above value, what I will get? dV equals to W1 plus W2. So D, what is the formula? V. W2 by M2 into 1000 by M equals to W1. Value of W1 is W2 by M2 into 1000 by M plus W2. We can take W2 common here. So our answer will be 1000 by M2 M plus 1. which will be cancel out, and m2 can be cancel out. Sorry, w2 we have cancelled w2. Now what's remaining? d 1000 by m2 m equals to 1000 by m2 m plus 1. This will be our formula. Now we will separate it. d by m is equals to 1000 by m2 m plus 1 into m2 by 1000. Let's multiply. First of all, it will get 1 by m plus m2 by 1000. So we can find out that d by m minus m2 by 1000 is equals to 1 by m. This is our relationship between molality and molarity if density is given. So what if molarity is given, molality given, density given? Then we can use this formula. Understood?